where the large Hadoop mix is actually able to take advantage of the idle resources in the cluster. And I mean, it has something like maybe 90% of the resources for actually launching its jobs. The blocky one at the bottom is MPI, and lots of different MPI jobs were being submitted to it, but it lives in this more rigid model, so it's not going to take advantage of any elasticity beyond once it gets its resources, just going to run. So you also notice that you'll see some white areas in the cluster, and that's actually when resources were idle in the system. So it would be nice if we just showed you a graph where we had this great system and there were never idle resources in the system, but that's just it's asking for too much, because we tried to actually run the jobs based on a job timing that we collected from, say, Facebook or other places, so that there are just some times when no jobs are currently in the system and there's nothing to be done. Okay, so now if we break down this this information a bit more, we can learn it much more. So what these graphs show, there's 4 graphs for each of the workloads. On the bottom is time, and the x-axis is the share of the cluster that has been allocated to it. So the blue solid regions are equivalent to when the job was statically allocated resources in the clusters. And the line is the resources that were allocated to the cluster when it ran on Mesos. So what you can see is any time that the line is above the blue bar, that was a time when it was able to take advantage of idle resources in the cluster to get other things done. So in the first, the upper leftmost graph, you'll actually see that the amount of time that it took to run those jobs in Mesos and not in Mesos is almost the same. However, with the large Hadoop mix, the one that's got a lot of lines above the blue regions, you see that it actually finishes its